So I chose REST because REST is one of the most utilized terms in our world. But actually, when you look at what REST actually means, you realize that, well, not every developer is having a REST API. So I chose to talk about the ignore part. So I'm gonna turn off my webcam right now. So my name is Irina. I'm a design lead and .NET Group community lead at Endava, which means I'm taking care of our internal .NET community in the company. And I'm also a Microsoft Valuable Professional for Developer Technologies. Today, we're going to talk about a few things. And if we have time, we're going to talk about OData also. So status codes, we need to know the most underutilized ones, HATEOAS, and versioning. So what is REST? And I'm going to say that REST is used everywhere, but actually implemented nowhere. And I dare to say that just because I've been there. I said I had a REST API, but in fact, I had an RPC API. I used verbs, I used, I don't know, different endpoints, but pretty much that was it. And by doing that, it meant that I ignored the true power of HTTP. So let's see a bit what are the REST constraints. And in a way, it's called constraints, but I rather call them guidelines because if those were constraints, everyone would respect them. So client server, stateless, caching, uniform interface, layered system, and code on demand. Code on demand we're going to ignore because nobody does that anymore. We used to do it .NET web forms at a certain moment in time. And let's take them separately. Client server. In REST, the server should not be aware of the client. Should be there to respond to the requests, and that's it. So the server should not care who is the client. Either it's a mobile app, either it's a browser, or whatever other service that calls the server. What it does, the server does data transformation under the hood, and nobody should care what are those transformations. The client should simply use those resources. So client server is the most simple pattern over there. There is a client, there is a server, and request response between them. Stateless. Uh, Being stateless means that all the mechanisms that we used at a certain moment, like sessions, hidden fields in the browser, I don't know, others, cookies of different scenarios are not there anymore, and we shouldn't use those. Caching. It says to be the most important spec of HTTP. And what it does is that the server must mark the response as being cacheable, and the client should respect that. And it may increase the perceived performance because it may save database round trips, especially if the data doesn't change often. How it's done is done through the correct usage of headers. We're not going to talk about those headers now, but there are a few of them, except cache control, that help the client and the server minimize their round trips. So if there is a specific data that doesn't change, I don't know, or changes once a day, if the client requests that data 1,000 times in that day, the server shouldn't have to go to the database and bring the same data back. So it marks the response as being cacheable, and the client will look at the cache data, at their expiration, and so on and so forth. Pair system. What it means is that the client can talk with an intermediate, and it will receive the resource it asks, but it doesn't matter if there's a load balancer involved in the middle, or a proxy, or a gateway, or whatever other system. So as long as the client receives the response back, and the response is the one expected, it doesn't matter what's in between. Uniform resource says that everything is a resource. And the resource is pretty much everything that can be named and that can have an URL. So a way of identification. A resource can be any document that can be read on the client, being a representation. Anything can be that can be read on the client can be an HTML page, a string of bytes, or pretty much anything that can be interpreted after is sent over the network. Uniform interface. Well, uniform interface is that constraint that has some other sub-constraints. And it talks about identification of resources, representation of them, about self-descriptive messages, and HATEOAS. So identification of resources says that each resource needs to be addressable. So if you have a resource over the internet, someone, and that someone being a client, should be able to access it. Doesn't matter how, but usually is done to an URL or to an identifier of any kind. So take care and make sure that a resource doesn't correspond necessarily to a database table. Usually we kind of do that because we're having an entity framework, and entity framework allows us to work directly with those entities. And due to the, I don't know, lack of time, we often use directly those entity framework classes. And it's not necessarily a good thing. So it can be a subset of a table of table columns, a transform entities, two entities joined together, but it's a representation. How do we, if we look at these, you see that these are very childish. So what are these? I'm going to ask you, what are these? So if I were to ask you, how would you represent everything in an API? What would you answer? So maybe you would go creating all kind of endpoints to represent dogs, to represent farm animals or foods or apples or fruits. But in the end, everything that we work with is a resource. And more than that, web, the World Wide Web, is a resource, contains resources. So let's take an example, a black cat. So let's say I have an API that manages cats of any kind. So one specific and correct endpoint might be something like that. I might want to get the location of that cat, right? Or maybe I need to add a new cat because maybe I'm a vet and I have a new patient and I need to register that patient in my system. And then I have an endpoint called new cat. Or maybe I have an automatic system that feeds cats. Or maybe I'm interested in getting all the cats in my system. Or maybe the ones that are only black. Or maybe I need to find out what is their hunger level. Or maybe I need to find out the cat owners. But if you look at these, you kind of need a documentation, right? Because these are hard to remember and are pretty bad because are not clear. Okay, and we'll get back to the endpoints. Okay, how do we manipulate resources representation? Well, since the client doesn't interact with the domain objects, and it sends back and forth the representation over the resource, it's very easy to decouple what we have in the database and what we have and sent to the clients. Another constraint is self-descriptive messages. What it says is that each request response, respectively, should include the details for that request response, because that request response should have meaning and it should be able to be understood in isolation. So if you take a request and you look at it, it doesn't matter if you know the domain of that specific API or business, and you look at the request, you should be able to tell what's asked in that request, right? So how do we add meaning to our messages that travel over the network from the client to the server and from the server to the client. So you have a request, respectively a response. You add meaning by adding verbs. You add meaning by adding media types, and not only the ones mainstream. And you add meaning by adding headers and by serving the correct status codes. So if you have all this, you're one step closer to having a full rounded REST API. Because in the end, REST means leveraging the power of HTTP. When it was first drafted in 2000 in Roy Fielding dissertation thesis, people started to understood that, okay, these are a set of constraints made for distributed systems. They cherry-picked a few things from there, but in fact, REST is fully leveraging the power of HTTP. Everything that is presented there, by adding meaning to the request, and every constraint for REST is basically HTTP. You have headers, you have status codes, and you have different status codes. I don't know, 63 of them, and we're going to have a look over them. Headers, you can pretty much add everything you want in headers that helps your business and helps the server to understand the request in isolation. So let's focus on this. REST is not necessarily a set of constraints. REST allows you to leverage the power of HTTP. So let's talk a bit about endpoints. So 2 URLs for each resource. So first of all, you have a collection. For example, speakers get all. If you look at the endpoint naming, you might understand that, okay, get all means getting all, everything that you have in the system. But how about having speakers, plural one, speakers? Well, speakers, it's easier to understand, it's easier to remember, and pretty much tells a lot of things about the resource that we're talking about, because you can utilize different verbs. So moving on, you have the collection, and then you might have an element. So you have speakers, get speakers, and you have the ID passed as a query string. How about utilizing the already known convention, speaker/ID? Okay. So moving on to the collection, you might use an HTTP GET to retrieve the entire collection. It doesn't matter if it's paged or not, but it's the entire collection. You might use post as HTTP verb to add something to that collection. And to the right-hand side, for the individual item, you get the item by using HTTP GET. You post maybe some related item, and you put or patch. So you update the item, and maybe you can delete the item. So what you have in here is pretty much the scenario that we all have in the businesses that we're working on, like CRUD, create, read, update, delete, because most of us at a certain moment said, okay, I have a REST API, and in fact that REST API was create, read, update, delete for specific entities. So if you look further than that, cool URIs don't change. So if you go there and create a new endpoint for absolutely every new scenario that you have, you will create a new URI, and it's not cool. Think about, I don't know, browsing the internet, bookmarking a page, and then after 2 days getting back to it, and you realize, okay, it's not there. It's not serving anymore the content that you expect. It's not cool, right? It's the same with the APIs. So what are the minimal guidelines for endpoints? So you should have concrete endpoints. You should have dogs if you're working with dogs, and not specific generic things that pretty much don't say anything about the endpoint. And if you have variations, like we had get all black cats, that's a variation. So if you have those, use query string, not different endpoints. Because in the end, your API will look like, let's say, not so cool by having all the variation as new endpoints in your API. So if we talked about endpoints, now we should talk about status code. Have a look at this. So this is a Postman snippet. So you have a status of 200 OK, which means OK. But in the body of the response, you have code 401 and a message. So looking at this, the client what should understand? The response is OK, was received successfully, and is able to process the body, or it's just an invalid API key. So use 200 OK when OK really means OK, right? Because other way, it creates confusion for the consumer. 201 created, and it should be used in response to a create, right? If you create and you add a new resource, then the response should be at 201 with the location header over there. And I know that I did it at this is a certain moment. I answered back with 200 OK when I posted something, because I didn't knew that a lot of status codes existed. So 201 when you create something new. 202 accepted is to be used for scenarios where you need to send something for processing, but you do not necessarily need the response body right now. So it's perfectly fine to use it. Okay, it's 200 accepted, and it's valid because it starts with 2. 2XX means that is success status. Okay, and the specific 202 means that is accepted. So use this wisely. 204. So 204, if you delete the resource, should be the go-to status code. Why? Well, if you delete the resource, what should you send back? I don't know, maybe you send a success message like, okay, this resource was deleted. But why would you do that? If it starts with 2, it means it is a success. And in this case, you do not need the content because the content was just deleted. 400 is bad request. 400 as a status code, it's often used in scenarios where it shouldn't be used. For example, if you have, I don't know, an internal business rules that doesn't allow the creation of a resource, maybe you shouldn't use bad request just because the client that issues the request doesn't know what internal business rules you have, and the request itself is well formed. It sends absolutely everything that the server should expect from the outside, right? 405. So method not allowed. When a resource is valid, but a different, I don't know, HTTP request method was used, like trying to delete a collection. Wouldn't be cool, right? Not acceptable. It happens, and it should happen if you allow it and you turn it on in Visual Studio. When the server doesn't know how to respond in the format specified in the accept header. Conflict. I often use 409 conflict when I have an internal business rule that says, okay, this cannot be created because something is duplicated, let's say, okay? 415 unsupported media type, and last but not least, 422 is the most misunderstood status code. You can configure Visual Studio .NET to return this by default when there is a validation error. I'm going to show you. So unprocessable entity should, in my opinion, be used when there is validation error, not bad request, but okay, unprocessable entity because of validation reasons, okay? And verbs, we all know these verbs, but how many of you are using had or options or trace? I just want to remind you that head gets everything back but the body of that resource, basically brings back the headers if you need them. And the options will allow you to see what are the options in your API. Like if you allow get, post, put, or delete, or patch, or whatever, you can use options to see. And if you ever code it in Angular or React or whatever, you're going to see that at first they do, when you issue a request from there, there is an options first and then the actual request. How about errors? So if you're looking at errors, there is already two standardizations, a problem JSON and API.json, that standardize the response in case of an error. So if you have something is forbidden in our case, you'll get back a specific format of the response, like with type, detail, instance, and whatever you want to add there. But the client will know that every time where there is an error, it doesn't matter what kind of error, the response will have the same format. Because nowadays, at least I had scenarios where in one specific case, the body with the error had nothing, and another case had, I don't know, a single message, but not every time there was that specific format for any kind of errors happening in the application. So one such as an example is problem.json. So you send back content type problem.json to the client when something happens. Something similar is VND API.json that standardized the errors format. So now you have an array of errors, and for each error, you have source, title, and detail. And if you look here, detail gives you the validation error that there is in .NET. Okay, let's have a short demo. So now I'm gonna start and show you there's a small API that is split in a few parts. We have the data that actually contains the repositories. You have the domain, where are the actual classes that come from Entity Framework, and pretty much this is it. And we have the API, right? So inside the API, we have two controllers. We have speakers that will pretty much implement CRUD. So we have get speakers that will return all the speakers, nothing fancy, just calling repository to get data from the database. Nothing fancy. And if we run this, I'm going to show you in Postman a few things. So first request is get speakers, right? Sending the request will get you back a 200 OK with the actual response. I have 100 records of dummy data in the database. So what happens is with the request, there is absolutely nothing sent in the accept header. So .NET defaults to JSON because this is how it's built. But if I'm interested maybe in getting only the headers for that specific request, I'm going to see that, okay, calling head on speakers endpoint going to get me back 405, which means method not allowed, and also a list of verbs in the allow headers. Okay, options on the same endpoint going to get me back 200 OK headers, get options and posts in this endpoint. And if we look in the Visual Studio, speakers, right? So I have a HTTP GET, which returns an OK with that data. And also I have an HTTP options that does pretty much, it inserts the allow header with get, options, and post. And this way I'm telling my client that, okay, on this specific endpoint, I support the get, options, and the post, and nothing else, okay? If we're looking at the endpoint for the speakers, you'll see that I decorated here only with get and not with head. And that's why I received a 405 method not allowed, okay? So if I'm going back and speakers by ID and say, okay, I'm making a head on speakers /1, I will get back a 200 OK and the headers. And that's it. I have absolutely, it's 200 OK because the request was received successfully, and I get back nothing in the body because that's what head does, and I receive the headers. Now, I do not have anything special configured in the headers, but if you have scenarios where you're interested in a custom header, then it is the right verb to use. Okay, on the same, sorry about that. On the same endpoint, I get back 200 OK, but now if I go here and change and add, accept and say, oh, I don't know, application /XML, and issue the request again, I get the 200 OK, but still a JSON body, which means that .NET Web API doesn't listen to my accept header. So it doesn't take into consideration this. So in order to enable it, I need to go into the startup and add in here for the fastness, I prefer to add commented code. So where you have the add controls, you need to have return HTTP not acceptable true at the first one. And another one, you should have options dot respect browser accept headers, because these are turned off by default. Oh, query params. Ignore me because I just added where it shouldn't be. See, now I get a 406 not acceptable because I cannot return application XML, and I just turned it on, right? It's not a 200 OK and this defaults to JSON. Now it actually does content negotiation and takes my accept header into account. And since I do not have XML configured for my application, it will respond with this, because basically the server doesn't know how to write XML. And if I add this, add XML data, contract serializer formatters, and I run it again, and I issue the same request, I should get back a not so nice XML format. It's the default one. I do not have anything specific, but now the server listens to what I ask. I said, okay, I want back an application XML. Can you write that for me? And he said, okay, I can give you back application XML. And here it is with the 200 OK, because I just enabled the data contract serializer, and now I can answer with XML. But if I want to get JSON back, I either add it in here and I will get JSON, or either not send it because it will default to JSON. Okay, and everything works just fine. Okay, so far so good. Let's see. If I want to create, let's say, the talks controller, by default, when you add a controller, a new controller, the route is like this: API controller, right? But if you want to link your resources in an hierarchical manner, like this, I want for the speaker with ID 1, all the talks, and you issue the request, you'll get back a 400 for not found. Because in REST, the theory says that everything that is hierarchically related should kind of look like this. Because when you look at the endpoint, you'll see, okay, I have the speaker, and specifically, I have the speaker with ID 1, and I want all the talks, the collection of the talks for the speaker 1, right? So what I do, I need to go here and change the route, and I will have pretty much half of it will be hard-coded, API speakers, and then I have the route parameter and then talks. So if I want to get talks in a way, I have no other option than passing the speaker ID somewhere in the route. Okay. So if I go to a Postman and issue a get now, I will get all the talks for that speaker. Okay. And if I want all the talks for that speakers, maybe in different format, now that I have that enabled, I will be able to get back the specific XML. Okay. Body. Just a sec to see. Cool. Let's get back to this. So if you look in the code, I have this returning entity talk v1 DTO that is pretty much has 3 properties that I map from the database, because in the first version is the only thing that I want to show. So sub-representation of my table. Okay. So let's see what happens if I want to post something to create a new talk. So I have like this, building a title and a description. Okay, if I issue the request, I need to check here that if the speakers exist, I will return a not found. But if the state is not valid, I will return a bad request. But if it is valid, I will send back, save it in the database, map it, and then return this, created at route. Okay, and if everything is just fine, I'll get back the ID of the newly created entity. I'll get back the 201 status code. And more than that, in the header section, I should have a location property for the new thing created. Okay, so if I go here and look in the body and take the ID, let's see if it works or not. 400 and 100. I'll actually get back the same thing, right? The entity that was just created. Okay, but what if I want to create something that I know will throw an error? So I have a super huge title, more than 100 characters, because this is the business rule that I wanted, and I get back a bad request. And what I have here is that title should not have more than 100 characters, and it has a specific format. I think starting with 2.2 version, Web API defaults to this format with problem.json. So I pretty much didn't do anything. Problem.json, which is the standard of the response, it's built in Web API. But let's say maybe you do not want this format, and maybe you do not want to send back a bad request. Then you can go and configure what you want. For example, you can go here and configure API behavior. Okay, so when you add the controllers, there is that method, configure API behavior, that will allow you to specify what you want to happen in case of invalid model state by passing the context and creating a new validation problem. For example, I want to return this type. Maybe in my API, I have, I don't know, a documentation of any kind where everyone can go and look over that problem. I need to have title, a status, and this time I want that my status to be 422, unprocessable entity. So I will go ahead and add that and run the application again with the bad request. You can tweak and tune in here to suit your business needs. So if I send this back, now I get back 422 with my specific response format. So you can go ahead and add your own documentation of and everything. So now I have my type. This is, I don't know, model validation problem in my API, the status, and see the error property for details. And here there is an array of errors. Okay. So now when something happens inside your application, it doesn't matter on which endpoint, the client will get the same response format. And it's very cool because it will expect the same thing pretty much. The only thing that will differ are the number of elements in the array. Okay, so let's move on. I'm gonna skip through this patch because it's not so interesting at this moment. But if you look back, configure API behavior is a very cool thing because you can return or all kind of things in here. You can create your own if you have a scenario. You can inherit this, you can override, and so on and so forth. Pretty much you can tweak everything related to the error. Okay, moving back, we'll talk a little bit about versioning. And I'm going to ask you, how many of you had this in the URLs? Like your API / com / v1 and then the endpoint. I did, but since cool URIs don't change, this will hurt evolvability. So there is a quote here from Roy Fielding on Twitter in 2013 saying that the reason to make a real REST API is to get evolvability. A V1 is a middle finger to your API customers, indicating, in fact, that there is a RPC HTTP and not REST. So having this V1 there, I wonder how many of your APIs remained until the end of life with V1 there, because you are afraid to change, because changing that endpoint would have caused you to change the client. I did, I admit. I am to blame for such an API. But what are your options? Well, you can version in the URL, but not in the root, right? Not in the path. You can version in the header and in the query string. So either of those are preferable instead of having /v1 and have your API die with that v1 because you cannot change that, or if you can't, you won't, right? Because I noticed that the tendencies in different teams is to, okay, I'm starting a new API, then I'm going to add a v1 there and do my coding and not care about that v1. So let's see a bit what are options about working with versions. Just a sec, because I didn't took this into consideration when I created. So I need to undo changes and get the other branch. Okay. So, and of course, there is not get restore. Whew. Okay. So as I said, we have a few options when versioning, but we also have a library that is very helpful to versioning. So we have our API, the same endpoint, speakers, one talks, and we issue a get, and we get a bad request. And as an error code, we get back that, okay, an API version is required but was not specified. And if we look in startup, by installing the NuGet package that is called, where is it? NuGet versioning, something like that. Microsoft ASP.NET Core MVC versioning, we can do something like this. We can configure, first we add the middleware, and then we can say, hello, API version reader is new header API version reader, and we say what is the format of the API version. So what it does is said, okay, I'm versioning through header, and my header should have API dash version. So if I go here now and go through this, then say, okay, I need to have, I don't know, version 1.0. What? Sorry about that. API version, let's say. And let's look at the talks. As semi-live coding, right? It should happen. Okay. Speaker. Get talks for speaker. What did I do? Okay. And now, fingers crossed. 401 runs. Okay. Whew. So I get back the response that I expect by sending the API version, because this is exactly the string that I specified in there. So why is it good? Well, it is good just because you have the option of changing the version or showing different versions in your headers without changing the URIs. And by not changing the actual URIs, you won't break your clients or consumers. So another options that you have is to go in startup and say, okay, I do not want to version to headers, but I want to add this in query string, because you can create a new query string API version reader. By not passing a parameter, it will create a default to the same thing. So let's run this. So version specified in query. Okay. Params. In the parameters, you see now that I appended API version and whatever number in there. And by sending the request, I get the response back. Okay. And another thing, maybe you want to customize the version, and you can go here and specify actually what you want. I do not want API version. I want a V, because that's what you think that is meaningful for you. So when you have a V, you need to go there and say, okay, it's still in query, but it's called V now, not API version. And by sending the request, you'll get back a right answer. Okay. Let's see if we have time to look at this. I will default to this header one, and I'm going to show you something. So by adding API versioning, you have a few options to customize for you. So you might want to say, okay, my default API version now is 2.0. Or you might want to say, okay, whenever a call is made to my API, the header should contain the API version. Or maybe you want to, if a version is not specified, you want to have a default one. And this is what it does: assume default version header when unspecified. API version reader, right? It's API version. And also, in case of errors, you might related to versioning, you might want to create your own provider, or if not, it's enough to use that. Let's see. Because I had a lot of scenarios. Okay, what's happened now is that I got back a bad request with a response code 101. Something went wrong while selecting the API version. And looking into the headers, you'll see that now I have two extra header properties, API supported version 2.0 and deprecated version 1.0, because I have version, just a sec. This is API version 1.0 and is deprecated. And I have this call, just a sec, I commented before, this one should map to API version 2.0. And also, if you want to increase your version number, you can add another controller, right? And by adding another controller, and C# allows you to name it differently. Now you can have talks for speaker, this actual method, into versions 1.0 and 2.0. What you need to do is to specify here the API version for each one and make sure that the API version is different. So this should have 1.0 and should not be deprecated right now. And with two versions side by side, should get back a response. What happens? Let's see, headers. Oh, I added 3, right? So if you specify a different version that is not part of your application, you'll get back an error. But if you want a correct one, something with headers, API supported version, API version. Let's see what's happening. And more than that, I'm going to show you, you can create your custom attributes to 100. Okay, yay, that was. Okay, so version 2.0, I have ID, title, description, and pretty much that's it. And let's say what I have in 2.0, if it's different or not. Yep, I have only 2 properties, the title and the description. So this is one way of having 2 versions side by side, just by specifying version over the controller. So this is version 1 and returns talk v1 DTO. That's why we should pretty much work with representation and DTOs and models and whatnot, instead of working with actual entities from generated by entity framework or from the database. And also I have talk v2 that is annotated with API version. And what it returns is a different object. So this object has only 2 properties, and v1 has only 3 properties. Okay. Another thing that you can do, if you find this notation, I don't know, strange, is to create your own attribute that can be used for versioning. So v2 is a custom attribute that, well, inherits API version attribute, and it adds pretty much under a different form, does the same thing as version. You have here overloads, you can have timestamps for the same attribute. It's pretty much neat. You can all add, I don't know, everything that crosses your mind in here by inheriting this. Okay. So you can also deprecate versions. I don't know if you noticed, but let me show you that v2 this works the same. So it's a matter of preference. You either use the platform, either you create your own and extend the platform, but it does the job. So API version 2.0, it returns the same thing. Pretty much it defaults to major and minor version as standard for versioning. So kind of this is it with the versioning. I will just undo this. So you can also tweak in startup to see what happens when you change this or enable and remove a few things from here. I will do the same thing because I need to change the branch. And another branch will be HATEOAS, the last thing we're going to talk today. Let's see. Okay, HATEOAS is the thing that we do not implement pretty much in REST. Hypermedia is engines of the application state, or also called the Hypermedia zoo, because there are so many of the out there, and yet we keep using the standard ones. So we're gonna have a brief look at this. Standard ones are the one that everyone knows. Application/JSON, XML, text, CSS, whatever else, but it's common and it's known for a while, and every junior should be able to say, oh, okay, I know this MIME type, are the one from the left. Custom media types are the ones that are pretty much new, but started to be standardized. JSON plus whole, VND collection, JSON, siren.json, IATF, RPC based are the ones that are standardized. Problem JSON is one example. And company specific are those that you create for your specific business and usually start with VND, my company, or whatever. Or when you have to, I don't know, serve different representation to different customers. So in order, you kind of do not want to have different version of the application, but you need to be able to serve the right response to the right customer, even if they have specific and different representations. Okay, so what is HATEOAS and why we do not use those? So in theory, a client should be able to navigate the app through links, pretty much like this. So with each response, there should be a section called links that tells the client what are the next steps to do. It's the same thing as we go to and surf the internet and you find links and we click through links and so on and so forth. Nobody tells us where to click. We just decide at the moment when you see the links, right? In the same manner, the client, the web app, the React or Angular application should be able to navigate through links. So what it does is usually the client should know the initial state and the next steps. So transforming the client as a finite state machine. So okay, from here you have these options, and from here you have these three options, and so on and so forth. So pretty much HATEOAS tells you how the next request is supposed to look like from the client perspective. Okay, this is about it, HATEOAS. We'll tell the client how the next request will look like, giving them options. So choosing an hypermedia format. There are all kind of formats, but pretty much all of them reduce to the same things, describing and adding metadata to the response. Choosing HAL is one of them. HAL is a hypertext application language. It looks kind of like this. You have a section with links, and in the links we'll have the href and maybe the operation or the state of that specific request. Unfortunately, to do that in .NET, you kind of do not have libraries. Another format is Siren that talks about different things, describes the entities, the classes, the relations, the URIs, and so on for every properties. This has an applicability for application where you kind of need to describe everything in detail, right? But it has the same concept in mind. The client will receive an entry point, some kind, and then from there we'll be able to navigate further. Okay, so action, Siren describes action, not only the links, describes states. And the most used format is something like that, customer or vendor specific, that looks like VND, and it's also called vendor specific media types. Why should you use something like this? Well, if you have application.json, is super generic. It tells absolutely nothing about the specific resource. But if you create something custom, not only that you will be able to serve several customers with several different specifications at the same time, just by utilizing headers and media types in headers, but it will add meaning to that request. So if you look at this, the format vnd vendor HATEOAS.json, and if we were to describe this, we have the top level type, which is application, is super common. And then we have the vendor prefix and vendor identifier, and then media type name. If you have want the links at the end, then you might add HATEOAS. And then you have the suffix. That suffix can be JSON, XML, or other custom formats that you have. But every media type that you will ever need to implement, it kind of looks like this, and it serves all kinds of purposes. More than that, it serves the purposes, but it adds the specific meaning. So Richardson maturity model says that you have four, in fact, levels of APIs. And that level of APIs tells how, I don't know, mature you are. And the majority of us is at level 2 without implementing HATEOAS, okay? And you should aim to have your API very mature. In REST, server is the one that drives the application state. By driving the application state, the two can evolve independently without affecting each other. And in the end, why should we care? Well, we should care just because REST-ish APIs almost fully use HTTP. We never implement HATEOAS. We kind of do not use the right headers and media types. Resource base is a fuzzy term, and also bad naming happens. And self-descriptive messages and everything that is in REST, we all did it, right? Because in the end, REST API should have verbs, headers, status codes, media types, and HATEOAS, okay? Because it happens when you have intuitive endpoints, you add meaning, you leverage the HTTP power, and also you can respond to different needs. It doesn't matter if you own the client application or client application is somewhere you do not know where. Having REST and HATEOAS allow you to have an evolvable API, right? And I think one of the reasons for that we do not implement HATEOAS is that we say it adds and it hurts performance, and then okay, nobody will use that, and why bother? Are no libraries out there. But let's have a look. Since there are no libraries out there, maybe we should contribute and implement something. We can also leverage, let's see, speakers is the chosen one. So in my speakers controller, what I do is to use simply .NET. And in order to do that, I have a link helper class, right? It's a generic one, whatever. And it has a value that is templated and a list of links. And every link has an href, a relation, and a method. So what do I do is that for each response, and depending on the media type that I will send, I create manually, unfortunately, the list of links for that. So I have a link for self, that's the current speaker, a list for update speaker, and for delete speaker. Okay? So I do this depending on the media type that I ask. So if I run this, I'm going to show you how I can implement custom media types. It's super easy. Okay, it's manual work, but this can be done in a more smarter way with a few, I don't know, minds put together. Okay, so I have in here HATEOAS. So get speaker with HATEOAS 401. send. As you see, I do not get anything back. I get only the response in JSON format. I do not have any other additional links. But if I send a specific header, and in my case is VND DNI speaker full HATEOAS.json, because this is how I decided. Okay, I send the request, and hopefully I will get back a response. See, I have this links section. And in this links section, let me see if I can get that. So I have something related to self, which is a get method that I'm allowed to do, and the speaker is the exact one that I requested. And then as options, I have the option to update the speaker on this link, or to delete the speaker with the delete verb on this link. Okay, so how it happens? Well, I'm passing the from header accept, and this maps from the header. And if I add a breakpoint here and issue the request back to show you what actually happens. So sending a request here will map the actual value that I sent, right? It's mapped from the header with the name accept, and it's exactly the thing that I sent. Okay, and moving on, I'm parsing that media type. Okay, so that parse media type, if we look at it, is application DNI speaker, blah, 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 but it has a lot of things. And if you look at it, you have the subtype, which is without the application part, and subtype without suffix, which is without the plus part, okay? And without the plus part means that maybe I can send plus XML if I need, and I will get back an XML representation with the links, okay? And simply, I just map to a full entity, which is exactly what I have in the database, and with the links, okay? And I have another option by sending friendly HATEOAS, which is sub-entity. And I do the same thing because it's pretty much the same method. And I think I'm running out of time. But I just check here, okay, it's the dummiest version that you can find with HATEOAS, but it works, it does the job. Okay, and now I map to a different entity. Okay, and if I run this, it's just value, first name, and bio with all the links there. So it's not the full entity, it's a friendly, something smaller. Okay, cool. And now maybe I want to change something and see, okay, I do not want to have JSON, I want XML. And let's see if I had it turned on. No, I didn't turn it on. So in startup, I should have HATEOAS XML. Let's see if I commented out HATEOAS XML. Okay, XML. Apparently, I had this one checked. Okay, you see, it's still a section with links and the response, but it's in the XML format. So this is how you pretty much do content negotiation. So what you need to add in here is produces, and produces will have a list of all your custom media types. And when something like that will be sent from the client, it will look here and say, okay, I have that, I'm able to produce that, then I'm going to serve you the response. Okay, so this is pretty much everything. I just showed you content negotiation, so there is no need to move through this. So yet again, REST means leveraging the power of HTTP, and the rest is not create, read, update, delete. Okay, don't confuse that. And maybe give HATEOAS a try, because it will really help your client and the server evolve independently. So you have here a few resources and also a very cool book, RESTful Web APIs, where you can find all the stories about hypermedias and pretty much everything related to REST and HTTP. And bear in mind that developing an API is easy, but designing it is very hard. So spend some time on designing your API because in the end, it will make your life easier and your customers or API consumers happier. So this is pretty much everything I had for today. If there are any questions, thank you for having me. I hope I had a few things that were interesting for you.
Absolutely. Thank you, Irina, for a very nice session, really good one. There are actually a couple of questions, and I'll start with the most pressing one that a lot of people have been asking, and that is the demo application available online somewhere?
Yeah, in fact, I thought in my GitHub, it's not private. GitHub, Irina Scurtu, in my Irina Scurtu, apparently it's private. I will create it. And also, you have 4 branches. Make sure you go through all of them. And you have everything in there. I will create it, make it public for you.
All right, cool, thanks. Then there's a couple of questions around designing the API, and I think those fall into the category of batching and multiple result sets and so on. So let's maybe start with that one. One is, imagine you have a request where you want to return, in your example, a bunch of talks based on multiple speaker IDs. Would you add those IDs into the URL? Would you do a GET request with the request body of the speaker IDs, or what do you think is the best approach there?
To be honest, I would use OData. Unfortunately, I didn't knew how to spend my time because I also had something with OData, so you'll find the example there. Pretty much everything that is a variation, either if it's a select of speaker ID, I would use OData in the query string in the URL. I wouldn't transform a GET in a post just to, I don't know, to send some IDs to filter. That's
all right, cool.
how would I do it.
Then something kind of related, imagine you have to update a collection. Imagine you have an API that has cats and there's 1,000 cats that you want to update. Would you do 1,000 requests, which is probably not a good idea, or is there a recommended way to do a single call to update all of them?
Again, how would I implement this? Since it's, let's say, a sensitive business, I would do a single request to update, but I would do it on a collection with maybe a specific header of any kind. But in any case, I wouldn't do 1,000 requests. So if it's something specific, like an action, do something. Indeed, in REST, it's very hard to represent. Because, I don't know, if you have a, I don't know, a calculator of any kind, compute something is something that sounds like an action. And pretty much updating a collection, it kind of sounds like an action. So what I would do is allow update on a specific field on that collection and have everything in one go. If it's, I don't know, setting a flag or something.
Yeah, so yeah, it depends.
Yeah.
When using HATEOAS and you're returning multiple entities and you maybe have related entities where you have nested entities or something like that, is it a good practice to also send navigatable links for those nested entities?
Yes, it is a good and recommended idea, actually, because each item in your collection will have, first of all, related links. So if you're on the root of the collection, you go on the first item, then you have the first items, I don't know, brothers, okay? So from there, you have like a finite state machine. So from here, you go there, from there, over there, and so on, and you're able to navigate.
All right, makes sense. Then, yeah, two more design questions essentially. One is, how would you name and which verbs and status codes would you use in an API for long-running procedures? Like, for example, you want to start an operation that takes 10 minutes to handle, and the response is not immediately available after making that request.
So first of all, when you send that thing to be processed, you will use 202 like accepted, right? And then you will just, from time to time, you'll just issue a GET request, and you'll send back a 400 and not 400, sorry, 200 and something. I'm missing the exact one. But there is a specific status code for long running processes. And in terms of naming that, well, I guess you have a resource that is processed, right? So if you have an endpoint for that resource, you can model it exactly as you would do for CRUD. Just use different header and different response.
Yeah,
and why not?
And what is your rule of thumb for when to send a 400 bad request versus the 406 not acceptable?
Bad request and not acceptable. Okay. So bad request is related to the request itself. And then when I say request itself, is like parameters that you send, body that you send, and so on. Not acceptable is related more to the what do you expect back as is accept header, not to the values itself. It's related to the headers that you send to the server and accept header that you expect in the response. So bad request, it's actually related to the content itself, not the headers or not the headers.
All right. Yeah, and then there's a couple more questions that I think people can easily find in the source code. So I'm going to end up with this one. Have you tried JSON hyperschema, or do you have any experience with that to basically specify all of the data structures and then generate the response types? Or is it too early to use that?
I think it's in draft or something. It's super draft. No, I've heard of it, but I didn't use it yet. I think it's submitted to our Internet Engineering Task Force, but it's still draft, I think. And I usually prefer not to work with things when are still drafts, except .NET Core when it first started.
All right, yeah, so probably a little bit too early still because it's still in draft. And to be honest, I don't think I've seen a .NET Core implementation yet.
No, it's just a specification, but I'm Googling right now. It's promising, but in the same manner, it was HAL. It was very promising, but we do not have libraries for it.